Welcome. So today we will see about one more alternative fuel which is growing very fast. Many people are predicting this as the future fuel. We are talking about this hydrogen fuel only. So what are the advantages, what is the speciality of this hydrogen fuel? So hydrogen fuel has high calorific value. What is calorific value? If you burn 1 kilogram of fuel, how much heat is coming out, how much it is liberating out. Normal diesel, if you take, it is around 42,000 or 44,000 kilojoule per kilogram. If you compare to diesel fuel, this hydrogen fuel you see it is having around 3 times of the calorific value. If you take about the fuel quality, first comes the calorific value. Okay. How much heat that fuel will give during the combustion process or during the burning process. So this is 3 times of diesel. So this is a very big advantage. And it can substitute for a wide range of application for hydrocarbons in a broad range of application. Hydrocarbon means this petroleum-based fuel. It has a lot of applications. Many places we can substitute as fuel, or we can use to generate electricity, or in various purposes also this hydrogen has. So its combustion efficiency is higher. What is combustion efficiency? How far the given quantity of fuel is burnt completely or combusted. It's called combustion efficiency. Whatever the heat present in that, it has to come out, or it has to convert into useful energy. How much we are extracting, how much it is there, how much we are extracting. Called combustion efficiency. I feel how to burn fully. Okay. The place where we are burning, the amount of the volume, chamber available, time given, everything matters. It can be used as a fuel directly, or can be used as a raw material to produce methanol, ammonia, hydrocarbon, using either carbon dioxide or nitrogen from the atmosphere. Okay. So in place of the automobiles, we can use as alternative fuel, or we can use to produce electricity using hydrogen fuel. And this hydrogen is also used in various applications. Many things we can produce. So from this. So hydrogen is chemically very reactive, and it is not found in its free state on the earth. It's chemically reactive. So hydrogen as such, separately hydrogen we cannot find. It is very highly reactive. Boiling point is minus 253 degrees Celsius. What is the boiling point of water? 100 degrees Celsius. What is the atmospheric temperature? It may be 20 degree to 40 degree approximately atmospheric air temperature. So minus 253 means below that only it is liquid. Above 253 itself, it is boiling and becoming gas. Next, auto ignition temperature is 585 degrees Celsius. It's very high. What is auto ignition? Another name we also is spontaneous ignition temperature. If the temperature comes, automatically that fuel gets fired or burnt. You need not give flame. Any solid substance you have, any fuel if you have, how it will burn, how it will start burning. Initially you have to give flame now for burning process. In automobiles, spark ignition is there. You are giving spark to the external device, the petrol engines and all. In diesel engine, what is happening? It is based on the auto ignition temperature. You are compressing the air or air fuel mixture to very high. As the compression ratio is high, the temperature and volume, the temperature will increase abnormally, and the temperature will reaches the, or it will increase above the auto ignition or self ignition temperature of the auto ignition temperature, self ignition temperature, and all same. A spontaneous ignition temperature are same. Our temperature will catches fire. So this is the temperature. Density 0.08 kilogram per meter cube. This is very, very less. In 1 meter cube area, the mass is only not only 1 kg, not only 0.1 kg, it is 0.0 kg. It is very less. Octane number is 130. What is octane number? Is the fuel rating for petrol engines. And cetane number is the fuel rating for diesel engines. Okay. So how for the combustion happen without knocking, without detonation. Okay. So 130 is good. Good fuel rating. Their characteristics are standard temperature and pressure. Hydrogen is a colorless gas, no color. It's a tasteless gas, odorless gas, no smell. Hydrogen gas is highly flammable and will burn in air in concentration between 4% to 75% by volume. Yeah, very highly flammable. Hydrogen is not toxic, but in its pure form is a chemical asphyxiant. What is asphyxiant? It will create suffocation. Only hydrogen is there, but hydrogen won't be exist normally. Okay, then it is not toxic also, but it will get suffocation. Okay, this an aspirant gas is a non-toxic or minimally toxic gas which reduces or displaces the normal oxygen concentration in breathing air. Okay. Breathing of oxygen depleted air can lead to death by asphyxiation, suffocation. In air, what will be there? Oxygen and nitrogen. In air, if oxygen is removed, then there's no meaning of air. Okay. Hydrogen gas leaking into air may spontaneously ignite. So there should not be any leak in the container or in the transportation and all. Application. See, very wide range of application. Hydrogen is used to make ammonia for fertilizer. Ammonia, very common fertilizer. Okay. Refining metals, all metal refinings. Many metals refining, we are using hydrogen. For making artificial materials like plastics, also we are using hydrogen. Hydrogen is also used as a rocket fuel, cryogenics, where liquid hydrogen is combined with liquid oxygen to produce a powerful explosion. What is cryogenics? Rocket science. If the gaseous fuel compressed and it is cooled, the volume will come down. In a rocket and all, you see the volume should be less, no? So the gaseous fuel will convert it into liquid fuel by compressing and by cooling. This is called cryogenics. Even normal LPG cylinder we use in the kitchen stove, you see, what is LPG stand? Liquefied petroleum gas. In atmospheric temperature, it exists as gaseous form. But if you compress and convert into liquid, then only you can put in the container. We can store it small. Otherwise, the volume will be very enormous. We cannot that much volume. We cannot hold. Transporting, using, and this will be very difficult. It's used in welding, arc welding, gas welding, oxygen, hydrogen, acetylene. Very common. Fuel cell. In fuel cell, a lot of combinations is there. In one video, we'll discuss about the fuel cells also. In basic type, or this is one hydrogen is the primary fuel for fuel supply. Fuel cell. Okay. Hydrogenation of fats and oils. Hydrating human body. Body cells absorb hydrogen. Used to remove sulfur from fuels during the oil refining process. If sulfur is present in the oil, sulfur oxides will come. Okay. So this is used to remove the sulfur from the oil. For filling balloons, hydrogen gas much lighter than air, however, it ignites easily. So a lot of the advertisement balloons and some balloons people can travel also. Those balloons are all hydrogen fueled balloons. Okay. Hydrogen production. What are the methods or from which sources hydrogen can be produced? Okay. The majority of the hydrogen, 95%, is produced from fossil fuel by steam reforming of natural gas, partial oxidation of methane, and coal gasification. You see, this is 90%. As of now, it is from fossil fuels. Other methods of hydrogen production include biomass gasification and electrolysis of water. This is very easy, but we need to give electricity here to produce hydrogen. Again, hydrogen is used to produce energy. It's directly that electricity you can use for your application. There are four main sources for the commercial production of hydrogen: natural gas, oil, coal, and electrolysis, which accounts for 48%, 30%, 18%, 4% of the world hydrogen production, respectively. Fossil fuels are the dominant source of industrial hydrogen. Okay. So, the steam reforming is one of the major, right? Partial oxidation of methane, coal gasification, coal what we used in thermal power plant. It that the coal need not be used as coal itself as solid fuel. We can convert the coal also as gas. We can produce, we can gasify the coal and we can use in the subsequent methods, many methods. Simple electrolyte cell. Okay, anode, cathode, water, we are giving current and hydrogen is produced. In the electrolyte solution, KOH is used to improve the conductivity. Here you can see KOH is required because water is very poor conductor of electricity. So 1.23 volt is sufficient for electrolysis of water at normal temperature and pressure. To produce 1 cubic meter of hydrogen gas, you require 2.8 kilowatt hour of electric energy. 2.8 kilowatt hour is like 2.8 unit of current. Okay. The efficiency of this method is around 70 to 80%. Operating temperature is between 50 to 80%. Okay. This electrolysis method is very easier method. Just water, you put anode, cathode, KOH, you add it to water to produce electrolyte solution, give current, hydrogen is produced. Very simple arrangement. Thermochemical process there, direct solar water splitting process there. Now this technology is improving by using the solar rays. Want to split the water. Okay, water is H2O. So if you spitting the water means H2 will be generating. Biological process from bacteria, microalgae. This algae is booming now. Okay. So this technology is also in the initial stage, and it is forecasted that these technologies will improve a lot in the near future. Then hydrogen storage methods. Hydrogen is very dense now. So in 1 cubic meter area, only 0.08 kilogram is there. So we need to think about the storing method. The compressed gas storage, 350 to 700 bar, we have to compress it for storing to put in the container for lesser volume. Chemical storage, you can use in the chemical format. Liquid storage, cryogenic storage in vacuum insulated or super insulated tanks. You can store as hydrogen liquid. Okay. The line pack system. So in the transportation, in the pipes, we can store, allowing the pressure in the transmission and distribution system to vary. Underground storage in depleted oil or gas fields or in aquifer. In any oil field, if you found below the earth surface and that is a removed oil or gas field, that will be vacuum empty. Those places can be used to store the hydrogen. This also you can do, but these places you can use it. Storage as metal hydrides. It is in metal form. In that we will store the hydrogen. By heating it, we can remove the hydrogen from the this hydrides. Thank you. In the next video, we'll see about some more topics related to that.